Alright, so in section 5, we're going back to the looking at the standard deviation and variance, trying to do a hypothesis test for those parameters. So suppose a mutual fund qualifies as having moderate risk if the standard deviation of its monthly rate of return is less than 3%. A mutual fund rating agency randomly selects 24 months and determines the rate of return for a certain fund. The standard deviation of the rate of return is computed to be 2.11%. Is there sufficient evidence to conclude that the fund has moderate risk at the alpha equals 0.10 level of significance? So we've done a normal probability plot, says that we are normally distributed. So we're talking about the standard deviation, and it's believed to be equal to that 3%. So we want to see if it's less than, so I see that qualifying word is less than 3%. So let's check that based off of the clues of the sentence, right? So again, your null is always going to be equal, your alternative is going to be less than, greater than, or not equal to. You kind of have to determine that off of what you've read. In this case, it says less than. So calculate the test statistic. Now when we do this in StatCrunch, again, we have to be careful because the way that we're going to calculate the test statistic doing variance stats is with the summary. So we know the sample standard deviation is that 2.11%, right? And the sample size is 24. But these are standard deviations, not variances that we need to plug in here. So 0.0211 is 2.11%, and I'm going to square it. So that gives me so 3 zeros, then 4452. If I do the same thing for my 3%, my hypothesize, that would be 0.0009, or 3% squared. And we said less than the 0.009. So once we have all that in, we have our test statistic, right? Here's my chi-squared test statistic. It says round to 3 decimal places, so 11.377. And that's not correct. Let's see what we did wrong. 3 decimal places. So that's not correct. 11.377. So apparently we're off by rounding a little bit on this one. I'm going to tell you that our answer is correct, and just this is hopefully a fluke with this one. We should be able to be within a thousandth of a value. P-value, let's see how this one works out. Our p-value we got is 0.021. Let's see how it does. Good. Just didn't like our test statistic. So if we look at our alpha and our p-value, Our p-value is lower than our alpha. If our p is low, the hoe gotta go. So since the p-value is less than level of significance, we will reject the null hypothesis, and there is sufficient evidence to conclude that the fund has moderate risk. So let's do one more of these, since that one didn't work out exactly how I had hoped with that test statistic. Let's look at number 6. So the data, table contains waiting time. So here we have data, right? Tests claim that the standard deviation waiting times is less than 1.5 minutes. So our standard deviation is 1.5 and our alternative is less than 1.5. So that seems pretty good. Again, we're not given a standard deviation or a variance or anything. So what we're going to do is we're going to take our data and we're just going to put it in StatCrunch. So our data is in StatCrunch, and we're going to do the exact same test that we did a second ago, except we're going to do it with data, not summary. So our data is in var1. It was looking that our standard deviation is less than 1.5. So again, we will have to square that. 1.5 squared should be 2.25. So that's what we'll put in here. And again, we said less than that standard deviation. And that's all we have to do. This computes our variance. It knows our sample size. And we will get a test statistic of 40.70. And we'll also find the p-value of 0.0332 or 0.033 to 3 decimal places. So again, using StatCrunch, it took the data. Since we're using a alpha of 0.05, our p-value is less than the 0.05. If the p is low, the hoe gotta go. So there is sufficient evidence to conclude that the single line reduced the variation among waiting times because HO is rejected, right? Because it's lower than our alpha.